Hi everyone, in this video we are going to learn how to create a neural network. But before that we are going to cover a little bit of theory. So these networks are inspired from our brain, and if you see this image where we have different layers, the input layer will depend on the input data set. So if you talk about the MNIST dataset where we have an image of 28 into 28, that means 784 nodes will be there in the input, and these data consist of different numbers from 0 to 9. So there are 10 possible output. So input and output will be fixed. In between that we can have different hidden layers. We have different activation functions like rectified linear or sigmoid. Now let's take one example. We saw a tiger inside a cage. So we might take a picture or take a selfie, but next moment if you realize tiger is out of the cage, I don't know about you, but I will run away as far as possible. So what happened in between when tiger was inside the cage and out of the cage? As soon as we realize it's out of the cage, our survival mode is activated, right? And we run away as far as possible, right? Now let's discuss about log softmax. In this example, we have defined list of list. So that's why I have given the dimension as 1. If this is a single list, then dimension will be -1. Now let's execute this line. Now we can see the output, and this will be normalized data. Using argmax, we'll able to find the index value where that number is maximum in that particular list. So let's execute it, and you can see we got 210. So first list has highest value at last, middle list has middle value as highest, and last list has first element as highest value. Next is optimizer. So if this is the loss functions and we are at this cross mark, then we wanted to minimize this loss to reach the minimum value, and each time we will take some step towards the minimum. For this model we are going to use Adam. Now let's download the dataset. We have seen this code earlier, so let's execute this code. So I'm going to import all these modules and going to import the dataset, transform, data loader. I'm going to define the transformer. Finally going to download the dataset, and then we are going to download the test dataset. Then we are going to split the data into different batches. So training and for test, both we are going to divide into different batch. Now let's create the model. So let's scroll down, and here you can see in the first layer we have 784, and the last layer we have 10 nodes are there. In between that we have two different layers with 100 into 100 and 100 into 50. Now we have the forward method, which is very important. Here we have different layers, and top of that we have rectified linear activation functions. At last we have applied log softmax, and dimension you can see it's 1. Now let's execute this. So model has been defined. Let's create an object of it. Now what we are going to do is just going to pass the data into this model, and let's model make some predictions. And here you can see model has predicted 3 for all of these inputs, but actually these are different numbers that you can see in the last line, 7, 0, 7, 6, 8. But right now we have not trained this model, so randomly it is predicting 3. Now let's train this model. So we have defined Adam optimizer, then we are going to pass the training data set, then we are going to get the output, then we are going to calculate the loss. Using loss we are going to calculate gradient using backward, and finally we are going to take one step in optimizer. Let's execute this code. We can see the losses here. Now let's re-execute this code. And this time it is able to predict most of these numbers. That's good. Finally, we are going to test this model with test dataset. And here we have defined two variables, that is correct and total. And then we have mentioned no grade, so that we don't want to change the gradient. And then we are reading this test loader. And using argmax, we see which number this model has predicted and is it the correct one. If it is correct, we are increasing the correct value. And let's execute this code. And this time we can see it has predicted with 96% accuracy. Thanks for watching.